Welcome to LNP Renewable System Integrator. Today we are going to discuss some of the basics of the electric vehicle part 9. So if you have missed out part 1 to 8, no issue. Please subscribe to the channel and and press the bell icon and get into our channel. In the channel we had provided the playlist. In the playlist you can see all the 24 parts that we have discussed regarding the basics of electric vehicle technologies. So in our videos we might be using so many abbreviations. If you have missed out anything, please refer to this part. So what are the things that we are going to discuss in this part? Today we are going to discuss some of the different charge depleting modes of Chevrolet Volt, okay, and how a vehicle target setting is done and what are its significance, okay, and what are the motor specifications with reference to the vehicle requirements, and how a speed torque characteristic of IC engine and traction motor looks like, and what are the requirements of a electrical vehicle traction motor. See here, this is an example of Chevrolet Volt. So today we are going to study regarding the charge depleting modes. Nothing but it is consuming the power from the battery and our vehicle is running. See here, in the Chevrolet Volt we have two motors. Okay, consider a situation, the engine is off. Now only one motor is running. So what will happen? It will try to consume the power from the battery through the power electronics and it will try to run the vehicle. Okay, consider a situation you plan to run in a normal mode. Now you are into a situation where you need to run your vehicle at a little high speed. You have a torque demand. Then in such occasions you need to run both the motors. So both the motors will try to consume the power from the battery through the power electronics and they will try to run the vehicles. See, this is an example of a kinematic architecture of this Chevrolet Volt. So we have two power modes. One is all battery electric and extended range. Okay, and if you are getting into the operating modes of these power modes, and for all we have the power sources as a battery. Okay, so when you try to run it at a low speed, only one motor will be running, and when you had a plan to run at a very high speed, then two motors will be running. Okay, and in the extended range, if you had a plan to run your vehicle at a low speed, then only one series motor will be working, and when you try to run it with a high speed, the two motors will be running. See here, this is an architecture overall view of a traction motor, and these are the gearbox supports, and this is your inverter, and if your motor will run as a generator, the energy getting stored. Okay, and this is a battery pack which is which will be present inside this vehicle. Okay, we have a rechargeable energy storage system inside the car. Now this is a charge sustaining mode. What is this charge sustaining mode? Simple. For this we are trying to understand it by considering the two cases. One is that consider a situation your IC engine is already running at 75 kilowatt. Okay, now consider a situation where you're trying to run at a normal speed. So what you're doing, you're running your IC engine as well as you're running your motor. So what will happen? One motor will try to consume the power from the battery to the power electronics and it will try to run your vehicles, whereas since the engine is running, the other motor which is idle, which will try to act as a generator, it generates the power. The generated power through the power electronics will get stored in the batteries. Okay, consider another situation where this is an example of a extended range. Here what you are doing, you're running your internal combustion engine so that it is driving your wheels directly. Okay, and now what is happening? Your second motor is trying to run as a generator, so the energy generator is getting stored in the battery. Now what you're going to do, you're utilizing another motor which will run as a drive unit, consumes the power from the battery through the power electronics, that is running your wheel, and at the same time you're trying to apply the brakes. So what happening, regenerative braking is happening. Because of it, the motor which was already running in the boost mode is trying to run as a generator. So what is happening, the power generated in the motor is getting stored in the, so the same motor is getting used as a motor as well as a generator. So when you're going for a vehicle target setting, it's very much important, because we have so many specifications, because based on the specification only the product is getting developed. So in the system level, so we will have a full vehicle conception. So in the same time, after once we have a design in the product, also we will have a full vehicle prototyping and testing and confirmations. When you get into the module level and the component level, we have so many mechanical, electrical and electronic components inside it. We will have a hardwares and the softwares. So everything we will try to design in the simulation. So okay, at the same time, when we are designing a actual vehicles, there we will go for a module integration in the testing, because what we simulated, whether we are getting it right or not, that confirmation will make. And apart from it, when you are making a component design, we use to do simulations as well. So at the same time, when you're developing a product, we need to do the component prototype testings also. So parallelly, both data information exchange should happen from the design to the implementation side. So when you're going for electrical motor or drive selection, so few more things that you need to know, that is, what is your motor specification requirement, okay, and how you're going to do the thermal management, okay, what sort of materials that you're going for electrical motors, and what sort of bearings that you're going to select for it, and what sort of control techniques that you're going to implement for your electrical vehicle, and what will be the inverted topologies that we're going to plan for electrical vehicle technology, and what sort of sensing requirements that your electrical motor require. So all these things that you need to know when you plan to design electric motor drive selection for your electric vehicle. See here, this is an example of a two-wheeler. So as we told earlier, based on the vehicle requirement, motor specification will change. Say for example, if your top speed, okay, if your top speed is from 0 to 40 km per hour, then here the torque should be maximum as well as the power should be maximum. Then you need to choose a motor where the torque and power is maximum. Okay, if you had a plan to run your vehicle at 0 to 100 km per hour, then there also you need torque and the power maximum. And if you had a plan to run your vehicle from 0 to 130 km per hour, then there also you have a maximum torque and a maximum power. Then you need to choose a motor which has both these specifications. And when you had a plan to run your vehicle from 80 to 120 km per hour, then the torque is not an important thing. The power should be maximum. Then you need to choose your motor with that specifications. So when we draw the torque speed characteristic of ICV engine and a traction motor, see here we have ICV engine and also we have ICV with the transmission gear. So when you draw the graph between the speed and the power, power is gradually increasing as the speed of the RPM increases. Whereas when you get into the torque, it was consistent for a particular RPM. After that, it is trying to reduce it. And when you're going for a transmission gears, it is shifting. So when you're at the first gear, it has one characteristic, and when you're at the second gear, it has other characteristics. So now when you get into the traction motor, see here consistently the torque is same for a particular RPM. After that, it is going to reduce. So when you plan for an electric vehicle, all these things you need to get into consideration. First is that you should have high power density, you should have a high torque density, and you should have a wide speed ranges, and you should have higher efficiency, and you should have a better NVH, that is noise vibration harness measurement. So that characteristic should be better, and you should have a reasonable cost, and you should have a high reliability, and you should have a high overall capability and a wide constant power. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have provided the contact details here. We are providing trainings for PLC programming of Siemens, Aluminium, Delta and PLCs. And if you had a plan to work in the GCC country, we are providing trainings for the building management system and the building automation control system. And you had a plan to implement the on-grid, off-grid systems for your homes or factories, then you can contact us. We are providing contact details here. And if you had a plan to establish the solar fencing for your agriculture farms, then you can contact us. We are providing as a kit. And if you want to know regarding the electric vehicle basic thing, you can contact us. We have provided the contact details here. Thank you so much.